already see what we got here. Okay, so find the kth character in a string game 2. This second part of this one from yesterday. I think I previously solved this somehow. Alice and Bob are playing a game. Initially, Alice has the word A. Give an integer k. You're also given an integer array operations, where operations I represents the type of the ith operation. Now Bob will ask Alice to perform all operations in sequence. If operations I equals 0, append a copy of the word to itself. And if operations I is 1, generate a new string by changing each character in the word to its next character in the alphabet. Okay. For example, perform operation C. On performing operation C generates CD. And performing operation on ZB should be like ZBAC. ZBAC, okay. Z becomes A, B becomes C, and then you append that to, so AC is appended to ZB, get ZBAC. Return the value of the kth character in the word after performing all the operations. Okay, so each operation should double the length of the word. So this is just doubling A to become AA to become AA. So this makes it 2 A's, and this makes it 4 A's, and this makes it 8 A's. And the fifth character is going to be an A. Input is 10. Okay, starts with A here. So this one should be A becomes example 2. A becomes 0 is AA, just doubling it or duplicating it, and then 2 A's would become 2 B's if you do the second operation. So it'd be AABB, and then you double that or duplicate that, and then the next one would be well, it's just the same start, and then the A's become B's, the B's become C's, so something like that. And the 10th character there is going to be this. This is 8, 9, 10. Okay. Gosh dang it. My eyes are just watering. Guess I'm kind of sick. Oh my god. Alright, K can be 10 to the 14th. It can be 100 operations. Alright, so pretty sure this, I think I kind of remember this being part of a contest that I did. And I guess I might have solved it before, after the or during or after the contest at some point. Surprising that I could solve any hard problems during a contest. Okay, anyways, how to do this. So, I wonder if I need to. Yeah, I think I just need to figure out the particular chain of like lineage for a particular index, and then determine where or how that progresses. So I'm thinking like I need the 10th character here. K equals 10, going backwards. 10. The 10th character is determined based on the second character from the last iteration. So the 10th character here is based on the second character here. And then the second character is based on second character of the previous. The second character of the previous is based on the second character of the previous, based on the second character of the previous, and then eventually based on the first character. Something like that. So 10th to 2 to 2 to 2 to 1. Okay. So for any given index, I determine what the index of the prior sequence and what the prior jump was, I guess. And then I determine the sequence. Yeah, okay. And then the prior jump from that, and the prior jump from that, and the prior jump from that. And then everything starts at A. Okay, so let me think about this a little more deeply here. So the 10th one is based on the second one prior to that jump. And the second one is based on the second one prior to the jump. The second one is based on the second one. And then this second one is based on the first one. And because this jump had it be the same, because this is a 0 operation, it's the same. And this character is A, so therefore this character is A. So maybe if I'd establish the lineage, if I establish that's 1 to 2 to 2, like if I know that this is the path to get to 10, the 10th character, and I know that this is A and this operation kept the same, and this operation was, what was it, 0, 1, 0, 1, so 0, 1, 0, oh, I had too many 2's. 0, 1, how do I think about this? 1 to 2 was, no, maybe I didn't have too many 2's. So the first operation was 0. 0 kept it the same, so it's A to A, and then 1 kept it the same because it was part of the thing that wasn't changing. Yeah, okay, so 0, 1, 0. So A, then first operation 0, then 1, then 0. Okay, there wasn't any 2 2's. So this operation is 0, operation 1, operation 0, operation 1. Actually, I'm not sure now. Okay, so if the index is in the portion, so if the index is in the portion of the string, if the operation is either 0 or the operation is 1 and the index that you're going to is in the portion of the string that is changed in the second half of the string that you're going to, then you will change the value here. So because this is in the second half rather than the first half of the next string, I guess if it's in the second half, no, yeah. If it's the same value, okay, so if the index is the same index as the previous one, then it's going to be the same letter regardless. If the index is in the second is a different value than the previous index, then it'll be the same value if the operation is 0, or it's 1 incremented if the operation is 1. How many operations is it? 100 operations. Okay, this is doable. So kind of identify the lineage, this lineage being the sequence of indices to get to a string that has k length, or has a k character. So just going from, creating this, I'm going to create an array that has like 10, 2, 2, 2, 1. Something that starts with k and ends with 1, or starts with k minus 1 ends with 0. I think I also want a powers of 2. I think this can be useful. So the number of operations generally is what I want for the powers of 2. This is really big. Do I want the powers of 2? K can be 10 to the 14. I guess so, that's fine. So I'm going to say 1, 0, 1, 1, while powers of 2, the last value that it has is smaller than k, smaller than or equal to k, something like this. Powers of 2 append double the last powers of 2. Okay, so see how that just works in general. So k is 5, so it's 1, 2, 4, 8. Okay, that's fine. K is 10, 1, 2, 4, 8, 16. Okay. So that's going to give me a useful kind of value to compare certain loops with. Okay, so let me go 10 to 2 to 2 to 1. Is it just going to be subtracting? So if I'll say lineage index lineage index history. I'll say history starts with k, and then I want to say if I compare 10, so if I have 10, I have a sequence 2, 4, 8, 2, 4, 8. So if 10 is bigger than the power of 2, subtract the power of 2 from it. Is that right? 10 is bigger than power of 2, subtract the power of 2 from it. Yeah, I think that is okay-ish. maybe I need to pop the last power of 2 because that's not necessary. Last power of 2. Yeah, look, the edge cases needs to be considered here, but for every power in powers of 2, not including the last one. Okay, so let's say p length is powers of the length of powers of 2. I created powers. Gosh dang it. I know I'm going to screw up the spelling of powers versus power. For every index in the range of p length minus 1, if powers of 2 at -1 minus index. So if I have 1, 2, 4, 8, 10, or 1, 2, 4, 8, 16, starting with 8, the 10 is bigger than 8. If that number is bigger than the last history value, then history.append history last history value minus the powers of 2. Okay, let's use our variables here. Let's say last p is powers of 2 at this index, which is -1 minus index. And if the last p is greater than the last history index, then history.append history last history is it greater than less than? Do 10 minus 8 and get 2. Yeah, so it should be no, it should be the other way around. If history minus if the last history is bigger than it. Yeah. I do history minus 1 minus last p. Append that. Otherwise, append the same, right? Otherwise, append the same. Oh, whoops, I forgot to return. Oops. Got a dummy return. That does fudge. So this should have been 10, 2, 2, 2, 1. I guess this is doing 16. -1 minus index. Yeah, this should be -2 minus index, I think. Yeah. And 2, 2, 2, 1. And here 5. So this one, the test case is the 5th character. Characters like this character. And this character is based on this character, which is the first character when it's the sequence. Based on the first character here. Yeah, okay. Wonder if there's a faster way of doing that. Yeah, it's fine. And then, so I have my history. So I have my 10, 2, 2, 2, 1. And And so I just need to go from reverse. So 1 is always the ending. 1 is always the ending, or 1 is always the last of this history. And I just need to have the correct logic for expanding it. So let's go ahead and say history, reverse it. That's more natural. I have 1, 2, 2, 2, 10, or like 1, 1, 1, and 5, something like that. 1, 1, 1, 5. Okay, so I can say if so 1 is always the start, so I can do I'll say the answer starts out at 0, which is answer being the ordinal value of A. Is that the ordinal value of A? Okay. This represents A, where A through Z is where 0 through 25 maps to A through Z. So if I have that, and I have a history of what does 1, 1, 1, 1, 5. So what do I say here? If it goes from one number and it doesn't change, then the character has to be the same. So for every index after the first index, so for index in the range of history, the length of history minus 1, 1 to the length of history. The value, let's say current spot is history at this index, and the previous is history at index minus 1. If the current matches the previous, so there's no, if some operation causes the character that I'm looking at to be the same, then the character, or the index I'm looking at to be the same, then the character has to be the same. So answer, well nothing changes then. So if it's not the same, then there's two cases. One where the operation was 1, or the one when the operation was 0. If the operation, I guess the operation would be at operations at index minus 1, because this is going from 1 to whatever. Index minus 1, or because index is kind of starting at 1, and I want to do operations index starting with 1 to map to operation 0, so it'd be 1 offset from that. If it's not the same, then it has to be some sort of, if this operation is 0, then no change. Okay, actually, the only time it changes is if the operation is 1. So I can say this is and operations is 1, answer plus equals 1, and then I just return the character value of this, the character mapping to this. So return the char of ordinal of A plus answer. Okay, I think this might be correct. Huh. Okay. I guess I try on full set. Wrong answer. Output is an empty space. Huh. That's interesting. Let's go ahead and just see what we see here. What the hell's going on? The number's too big, I think. Huh. Interesting. The number's too big. I mean, this number is, I guess, what is the biggest? I think this is bigger than the biggest number that you can have as an integer, maybe. But then why is k allowed to be that large? I see, I see. Yeah, I see. I'm assuming this is fine, and then this doubling goes past the bounds, but then this value is the biggest number possible. Technically, I didn't need that last value anyways. I don't think. So while it's less than k, I think maybe I can say while this thing times 2 is less than k. I guess less than k, pen 2 times it, and then always pop it. Because I never want to really subtract itself. I guess maybe powers of 2 dot pop, and then at that point I can just ignore the last, or don't worry about subtracting 1 from this thing anymore. So I can just say here should be length of powers of 2. Okay, let's see if this is what I'm thinking of. Oh yeah, at this point it's just being -1 minus index. Okay, so history is still not good. I thought I removed the last powers of 2. Powers of 2 that pop. Okay. Interesting. Okay, history should actually have this number, that's right. whatever billion trillion. Okay, that looks fine actually. So why doesn't it work? Index 1. Let me go ahead and just print out the answer each time, I guess. How is it even 0? Oh, am I not doing mod? Oh my god, this is so stupid. Answer equals answer mod 26. Answer equals answer plus 1 mod 26. I'm so stupid. Just absolutely bonkers dumb. I forgot to loop it around. Well, it's not a contest, so I can do this as much as I want. Can't really do test cases then, or debugging in the contests. Okay. Could I have done this better? Yeah. I could have done this better in the sense that all this calculation of powers of 2 could be on the fly, I think. Like, you can do powers of 2. You don't even need to calculate powers of... yeah, I didn't reference the powers of 2 within this thing, right? So I could have done this on the fly. I wonder if I want to rewrite this so that it's more efficient. Like for instance, like if I see this code, I can see it almost clearly. I have a better grasp of the thought process or the decomposition of what parts are necessary, or what were the major ideas to get to the solution. When I see, well, you're creating an array of powers of 2 because those powers of 2 are necessary in the calculation. They're very necessary. Versus if I were to do a more optimized solution where I'm like going through the index k and then deriving the history of k down to 1 in one pass, and then in that same pass like doing the logic of calculating the powers of 2 that would be the comparison within that pass of the current like spot versus the next spot, and then within that same kind of pass, within that same loop, also determine whether or not, based on that comparison, the answer should be like decremented or not. That all kind of makes the logic more complicated. Like it's a lot harder to see what exactly is going on. So I might be fine with this runtime. Although maybe as a challenge I should probably do the other way, so kind of the more optimized way. And kind of demonstrate why I think this would be maybe easier for other people to understand even if there's an efficiency loss. So it would be something like for every hash. So I would first need to identify what the powers of 2 that is slightly less than this would be. So what is the best way of doing that? I think it's something like I take the log base 2 of the value. Closest power, closest p, or power of 2. I think it's going to be, oh gosh, math log, base 2. What is the arguments, or what are the logarithmic things here? Logarithmic functions, log 2, specifically for calculating base 2 logarithm. Log 2 is generally preferred for scale values due to slight performance advantages. Okay, let me go ahead and just verify that this is what I want. So I think it'd be, the power is log 2, the number, and I think I make this into an integer. Make it 2 and then do 2 to that power, I guess. I wonder if this works if it's exact power of 2 though. If it's an exact power of 2, then it's going to be exact. So I think maybe this thing should be -1, k minus 1. But if it's k minus 1, then what happens when k is 1 in the test case? Then I'm doing log of 0. Ugh. Doing log of 0, that's going to be undefined. 2 to the power of what? If k is 1, I could maybe just make that into a special case. K equals 1, then just return 0, or return a. I think then I can make this fine. So if k is 2, log base 2 1 is going to give me 0. 2 to the 0 power is 1. I think that's fine. Okay. So those are the powers of 2. And I think I can say something like for so while powers of 2 is greater than 1, greater than or equal to 1, while powers of 2 is, so if k is 2 and powers of 2 is 1, yeah, if I do 1 divided by 1, it gives me 0. Okay, I can do while power of 2 is greater than 1, greater than or equal to 1. So that mimics the last p within this loop. So either it changes or it doesn't change. And it changes if the powers of 2 10 becomes 2. Yeah, it should always change. The first thing it should do is it always changes. Or it's always above the thing. Okay, so say the answer is initially 0 still, and then if powers of 2 is, let's say if k is greater than powers of 2, power of 2, then it's going to change, right? K minus equals the power of 2. And if it changes it, then this has a chance of making the offset. If the operations, oh gosh, I kind of need an index tracker here. I guess I can maybe do the operations, the last operation at this point. Guaranteed to be this thing, operations. If last operations is equal to 1, then answer increments. Oh, answer increments within the loop of values from 0 to 25. Regardless, I want to have operations.pop each time. I want to have power of 2, like divide equals by 2. And then I return the character version of this ordinal a plus the answer. Oh, this is mod 26. 26 characters. Oh, wrong answer. Okay, so 4. So some power of 2 that's screwing this up. Odd that doesn't screw up on something smaller than k equals 2. So 4 minus 1 is 3. Log base 2 of 3 is going to give you 1 and change. So 2 to the 1 power is going to give you 2. So 4 becomes, okay, I may map this out here. K is 4. Operations A, first operation is 0, so it's 0, 0. So it's AA. Next operation is AA. Ah, I see. So the fourth character doesn't need this one operation actually to calculate it, so therefore it's going to be offset. I was thinking operations would give me the minimum set of things needed to get to K. But here, like this one is not necessary. This one is not necessary to be used. So therefore I'm using the wrong operations within this deal. So what I think I need to do is I need to limit operations to just the stuff I want. So for I think it's something like min ops is going to be math.log 2 of k minus 1, integer value of that. And this is 2 to the power of min ops is going to be the power of 2 that I'm looking at, I'm most interested in. And then I'm going to go ahead and say operations is just operations to the min ops number. So from the start to min ops. At that point it should be fine, I think. Oh, oh boy, k equals 5. K k equals 5. So 5 minus 1 is 2, 4. 4 log base 2 of 4 is 2. So 2 operations. Maybe this should be. Okay, what's the logic here? What's the logic? So 4 gives me 1 operation. No, 4 should give me 2 operations, right? Yeah, so I think this should have been min-ops should be plus 1. Still wrong. Sad, 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 sad. Let's go ahead and just do print out what min-ops is. So that's 3 operations. I think that's the right number, no? So A goes to double A goes to quadruple A goes to 8 A's, or 8 A's at K 5. So am I misspelling operations? So it's 3. Operations equals operations from 0 to 3. But pop 1, pop 2, pop 3. Okay, what's going on here? So the power of 2 initially is going to be 4, right? Oh, I see. Power 2 is now off. So this should be, the min-ops should be plus 1 there, but the power of 2 should be minus 1 here. Okay, that took me too long. Shouldn't be changing things without really thinking about them. But sometimes you gotta do what you gotta do to minimize your brain energy. Okay, so yeah, this is the condensed version of this, and this is kind of the expanded version. This is the condensed solution, which is like, I'll quote this as more efficient, but harder to understand logic, I guess, which is often a trade-off that you make when you want to make your code super short. And this is the longer version. More decomposition of logic. Okay, so here, so I guess this is kind of the wrap up. You want to, I guess, okay, summary would be what? A kth character will have some kind of lineage or history of which characters in the sequence in the strings created to get to to get to that kth character. So for the example I'd use was 10. What was it? So for the example 2, where you had A go to AA to AABB, 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 BBCC, BBCC. So if you have the first character, this becomes the second character, which becomes the second character to the 10th character. Like the 10th character here is created from the second character here, which was created from the second character here, created from the second character here, created from the first character here. Or basically 10 was from the 2, from the 1. So first determine that first is to create or determine that sequence of indices. Second is to 1. Second is as utility, kind of have an array of powers of 2, since create an array of powers of 2 up to power of 2 up to power less than k, or powers less than k. And then actually that's in the reverse order, right? First create the array of powers, then create or determine the sequence of indices by comparing current index starting with k to power of 2. And basically the index stays the same in history if k is less than power of 2. Index is decremented by power of 2 if greater than k. If k is less, if k is greater than power of 2. So that was this thing right here. And basically 10 is going to be bigger than 8, which is like, if I think about this as compared to power of 2, it's going to be 1, it's going to be 1, 2, 4, 8 in terms of sizing. So because 10 is bigger than 8, then it's going to be based on the second index in the previous one. And then since 2 is smaller than 4, then it's going to be still 2. 2 is smaller than 2. 2 is not bigger than 2, then it's still 2. Eventually 2 is bigger than 1, so 2 minus 1 is 1. So that's the order of where the relevant character is within each successive string that we created. And then use logic to determine what the initial A does to become the kth character, and basically only changes the character only changes if the index change and operation at that um, and current operation is 1. So when I go from 2 to 10, or when I go from 1 to 2, the operation that was relevant was the first operation, which was 0. So it didn't change the values. Everything inside the string basically became the same, kind of copied. But when we changed from 2 to 10, the operation there was 1 based on the indices, and the operation incremented the value from A to B. And then no, create loop to change answer value while iterating over operations using logic. So that was this thing right here. So you start with your answer being 0, you go over the indices of your operations that are relevant. I guess you could, well, here I did it going from the index 1 to 2 to 2 to 2 to 2 to 10, whatever. Pairing the two indices if they're the same, and if the operation was a change operation, answer becomes one more mod 26 to make it go to 0 if it's C's plus 1, and then return the ordinal. And then again, the way that you can make this more efficient would be to have a single loop that kind of does everything. So first calculates the relevant power of 2 that you'd be doing. It eliminates operations that were not necessary to get to the kth character. And then while the power of 2 is bigger than 1, which is, or bigger than or equal to 1, which is kind of the last breakpoint, it's going to compare k to power 2. If it's bigger than power 2, decrement k. If it's a change operation, when it changed that k value, then it changes the answer by 1. Then it kind of removes the operation, and then it decreases the relevant power of 2. Okay, time complexity, this is going to be O of log k, since number of operations needed is scaled by power of 2. So like if you're dealing with something like, say, the thousandth character, k is 1000, then you'd be tracing back to 500, tracing back to yeah, this is, yeah, this is should be pretty straightforward to see that you're not going through every k value. It's not linear, and you're jumping based on powers. So since the number of options is scaled by power 2, okay, the kind of size history or the length of the history / lineage of indices up to k is basically jumping based on powers of 2. So therefore the length of that powers of 2 is log of that. Space complexity is going to be O of log k if for the kind of inefficient longer solution as it used an array of powers of 2 and an array for lineage history or history index history. More efficient solution does this on the fly and thus and doesn't have extra array, so thus that's O of 1 constant space. So this other solution was much more efficient in that regard. All right, cool beans. This one has a lower acceptance rate than I would assume, based on how hard it is in my mind to do this versus some of the other ones. Maybe my understanding of acceptance rate and difficulty is